Anmol. And when I say Anmol, I mean everybody else in the further maths group facing the FP2 exam as well. Let's have a look at this type of question where we have the argument of z minus 3I divided by z plus 4 equals pi over 6. Now, we know and we remember that we can rewrite this as arg of z minus 3I minus the argument of z minus 4 equals pi over 6. So now we find we've got 2 points. We've got a point here, that's at plus 3I, and we've got a point here at minus 4. And the half lines run off from here, or in that direction or whatever, but we don't know. However, if we take an angle greater than pi over 6, and a very suitable one is pi over 2 for the argument of z minus 3I, so let arg of z minus 3I equal pi over 2, we have a very simple sum, pi over 2 minus arg z minus 4 equals pi over 6, and that argument of z minus 4 here turns out to be pi over 3 by a simple subtraction. So let's draw in this argument. The half line, the initial line from here would be there, and pi over 2 is going to be going straight upwards. Now, we try arg of z minus 4 equals pi over 3, and that's an angle of 60 degrees, which is going to take us up there. And we form an angle which is pi over 6. And we can see that pi over 2 minus pi over 3 does indeed equal pi over 6. So we know that this is a point on the arc that's required. If I join in this line here, whoops, that's going to give us, so we know that we're going to get a circle going round like that, or rather an arc of a circle, part of a circle going round like that, because it all fits together. Now if we follow this method in the second case down here, then we're going to have 2 points. We can read it off this time. We've got the same one where we're going to set off our 1, 2, 3, there's the half line, and we're going to have it running vertically from there, because we're going to take arg of z minus 3I as a pi over 2 again. What's the other one going to be? I think it's probably pretty obvious with a couple of steps that arg of z minus 4 is going to be pi over 4. You can work that one out for yourself. This time we're on the right hand side. 1, 2, 3, 4. And here's our initial line for the argument of z minus 4 going out in that direction. And we're going to form a 45 degree angle. And you can see that that half line and this half line don't meet. Therefore, it must be in the other segment where the action's taking place. So let's now draw this line down here. And we can see that there's the initial line. That's 3 pi over 4, isn't it? 3 pi over 4. And This one is now going to be minus pi over 2. It's going to have to, the half line is going to have to come downwards. And we're going to have, let's try and get it straight, minus pi over 2. That's going to be argument of z minus 3i. Take away minus 3 pi over 4. And that does indeed give us pi over 4 as required. So we know that this time the arc is going to be coming round in this direction. There we are, that's pi over 4. If we wanted to know where the centre of the circle was, then we would know that the angle at the circumference is half the angle at the centre, so we're looking for an angle of pi over 2. And we also know that if you find a perpendicular bisector of a chord, then that's going to give you a line which goes through the centre of the circle. So we're looking for an angle of 90 degrees, and by the symmetry of it, well, that would have to be 45, 45, 45, so we can make it look nice. There it is, that must be the centre of the circle that we're looking for. So that length, and that length would all be radii. So that's how you can cope with this. Quite simply, choose an angle for the top arg, choose it as pi over 2, and see whether you're going to get the half lines meeting above or below the chord, in this case between 0, 3i and minus 4, 0, and in this case between 0, 3i and 4, 0.